Hey, what's up? I'm Mr. Bahork, and we are looking at point slope form today. And point slope form is just another way to write the equation of a line. We're going to talk about three different ways to write the equation of a line. We've already done slope intercept. So if you haven't watched that video or haven't learned about slope intercept, you need to do that before you even start this video. And now we're going to learn about point slope form, which is just another way to write the equation of a line. And then we'll do standard form, which is yet another way to write the equation of a line. So they all have their uses, though, I promise. And we'll talk about point slope form. And point slope form, it gets its name from a very, very simple concept. If you are given some point, let's say it's x1 and y1, some point, some random point, some x value and y value, and you are given a slope, okay, m, okay, and we don't know what that is, so I don't even know why I wrote an equal sign there. But if you're given a point and a slope, then you can write the equation in point slope form, hence the name. So here is point slope form. Okay, we have y minus y1, the y coordinate, equals m, and I'll put that in pink. There we go. And m times x minus x1, which is going to be in orange. Here we go. And that's it. I know it seems kind of weird looking, and it is. It's kind of weird looking. Okay. So the x1 and the y1 come from your point that you're given, and m is your slope, and the x and y, like any equation of a line, are your x and y values. Your numbers, like when you get your ordered pairs, you plug them into that. So let's take a look at an equation in point slope form, and we'll graph it. Let's say we're given y minus 3 equals a slope of half and then x minus 2. Alright, so we're going to need a graph. And there we go. Alright, so let's see what we got here. Well, I know that the slope is a half, so that one's easy to spot, so I'm going to write that out first. And it actually helps writing out what you actually have. And what else do we have? Well, we do have a point, but be careful when you're reading it, because this is really the only tricky part about point slope. Okay, you notice how it says x minus 2? Okay, and it's x minus 1 in the format. That means x is 2. Okay, it's not negative 2. X is 2. Okay, because it's supposed to be x minus whatever the x value is, and the x value is 2. Be careful there. Y value, that's 3. Okay, remember, it's y minus y1, so y value is 3. I'll show you an alternating example in just a moment. Okay, let me finish graphing this one now. Well, if we've got that point 2, 3, point slope, so 2, 3. Awesome. It's a pretty sloppy point, but okay. And we got the slope, it's 1/2. So from that point, go up 1 over 2. And I'll do it again, just make a straighter line. And there it is. That's our line. So it's not that bad. It's just kind of weird to read. You got to get used to reading the format. There's my line. It's all pretty looking. Now, let's go backwards. Everybody got that line? Good, because I'm going to go backwards. Cool. Now, let's go back. I was talking about this minus 2 and minus 3 part, so let's change it up a little bit. Just let me erase some stuff. There we go. Okay, so let's do a new equation. Let's say I'm giving y plus 5 equals negative 1/3 x plus 1. Okay, so be careful here. First thing I'm going to identify is the slope, because that's easy. It's always on the outside of the parentheses. So m equals negative 1/3. Sounds good. All right, now the point, though. Okay, be careful with your point. Remember, the format is supposed to say x minus x1. So whatever they plugged in here somehow made that minus sign into a plus sign. Well, if you think about it, let's look at what they plugged in. It must have been this. That's the only way we could have made that into a plus sign. Minus a negative turns into a plus. So they must have plugged in a -1 for the x value. This is true for over here as well. Okay, if this is supposed to be y minus the y value, then they must have plugged in a -5 in order to make that a plus, because a minus a negative is a plus. So the y value must be -5. All right, so let's look at that point. Back 1, down 5. So that's down here. And the slope is -1/3. So go down 1, right 3. 1, 2, 3. I hope I counted that right. I'm having trouble seeing it. Yep. Awesome. And those are the 2 points I need to make my line. And I did all of that from point-slope form. Okay, I didn't even know the y-intercept. Didn't know it at all. Okay. Well, speaking of the y-intercept, and speaking of maybe slope-intercept, there's an easy way to go ahead and make this into slope-intercept form. So let me erase some stuff and show you what I'm talking about. Alright, so let's say you're given the equation in point-slope form. Let's say you're given y minus 4 is equal to, I'll go with 3/4 as the slope, x plus, I don't know, 8. Alright, so let's actually change this to slope-intercept form. I want y equals mx plus b. Well, you notice y is by itself, so we need to solve for y. We need to solve for y. And in doing so, if you look over at the point-slope form of the equation, okay, all we really need to do to solve for y is add 4 to both sides. Okay, add the 4 to both sides, and then y is by itself. But right here, we've got like a lot of mess going on. This is not simplified. And we want something x plus b, and this parentheses are kind of in the way. So what do? Distribute. We distribute 3/4 to both of these guys. So let's do that before we add 4 to both sides. Okay, let's distribute 3/4. So 3/4 times x is just 3/4 times x, or 3/4 x. And 3/4 times 8. Take a second to do that. Okay. It's like doing 3 over 4 times 8 over 1. Okay, 3 times 8 is 24, divided by 4, so 6. All right, and now let's add 4 to both sides. Plus 4. Those cancel out, and I got y is equal to 3/4 x plus 10. So there is the exact same line, but now it's written in slope-intercept form. Let's graph this, just for fun. I hope I have enough room to graph. Oh, goodness. Well, I'll show you a little trick. Okay, you'll like this. So the y-intercept is 10, so I'll go ahead and put my point at 10. Sounds good. And the slope is 3/4, but if I try to graph that, I'm like way off the graph. So here's a nice little trick you could do. Well, isn't 3/4 the same thing as -3 over -4? A negative over a negative makes a positive, so it should work. So go down 3, 1, 2, 3, back 4, 1, 2, 3, 4. Aha! And now I can graph that very easily. Now let's test something out real quick. Okay, this will be fun. So the point slope, this equation right here is supposed to be the exact same thing as this one. So let's look at what point they're asking us to plug in. And we're going to see if that point lines up with our other two that we used from the slope-intercept one. So the x value must have been a -8. A -8 because it's a plus. If it's a plus, that means they must have plugged in a -8 right there. Okay, because a minus a negative is a positive. And the y value, well, that's a 4. Okay, y minus 4. So -8, 4 should line up nicely with what we've done here with slope-intercept. So let's test it out. Okay, so -8 and then up 1, 2, 3, 4. Oh, look at that. Look how nicely that lines up. Okay, so you can see that both of those equations represent the exact same line. Okay, there's no difference between them. They sure do look different, but they represent the same line. All right, that's about all I'm going to do at point slope form for today. I'm Mr. Bohoric. Again, that was point slope. Hope you enjoyed.